Numbers, numerals, and addition. The first numbers developed were the natural numbers, also called the counting numbers 1, 2, 3, 4, 5, etc. The three dots means that these numbers continue forever. There is no largest counting number. Think of counting objects as you put them in a container. Those are the counting numbers. Natural numbers were used before there was history. All people used them. This counting stick was made more than 35,000 years ago and was found in Lobombo, Eswatini. The cuts in this bone record the number 29. These were and are still used to count objects: goats, bales, bottles, etc. Drop a stone in a jar or cut a line in a stick every time a goat walks past. That jar or stick is a record of the number. Numbers exist even without a numeral, such as the number indicated by the cuts on the Lobombo bone. A numeral is the name we give a number in our culture. If asked how many tires my car has, I could hand someone the above marbles. That number is represented by 4 in our base 10 numeral system, IV in the Roman numeral system, 100 in the base 2 numeral system, or you could even use tally marks. 4. Adding 0 to the counting numbers gives us the whole numbers: 0, 1, 2, 3, 4, and so on. Counting numbers were developed more than 35,000 years ago. It took 34,000 more years to invent 0. This, the oldest known use of 0, which is the dot here, was found about 1,500 years ago. It was found in Cambodia, and the dot is for the 0 in the year 605. Here's the reason why 0 took so long to invent. Here you have 3 horses and 3 houses, 2 horses and 2 houses, 1 horse, 1 house. But when would you ever really need to say 0 horses or 0 houses? Would I tell someone I have a herd of 0 goats, or a garage with 0 cars, or that my 0 cars have 0 tires? 0 just isn't a natural number, but it is a whole number. The simplest mathematical operation is addition. Each time a marble is dropped in a jar, we are doing addition. The number of marbles in the jar is the number you started with plus the number you added. This illustrates how addition works with the whole numbers. A number line allows us to think of addition in a new way. With the number line, instead of dropping marbles in a jar to do addition, you take steps to the right. So here we can start at 0 and we can add 4. 1, 2, 3, 4. And if we want to add 5 to 0, we start at 0 and we add 5. We move to the right 5 places. 1, 2, 3, 4, 5. Let's find the sum of 4 and 5 on a number line. The number 4 is 4 steps to the right. So starting at 0, we add 4. 1, 2, 3, 4, and now we are here. The number 5 is 5 steps to the right. Starting at 0, you would end up right there. To find the sum 4 plus 5, start at 0, take 4 steps to the right, then starting where you ended after those first 4 steps, take 5 more steps to the right. If we were walking, we could look down and see that we were standing at 9. Therefore, 4 plus 5 is 9. If the order in which a mathematical operation is done doesn't matter, the operation is called commutative. In this case, addition would be commutative if 4 plus 5 equals 5 plus 4. Let's test that. You can see below that the order in which the addition is done does not change the result. The result is 9 for either 5 plus 4 or for 4 plus 5. Therefore, addition is commutative. The specific numbers we used don't matter. Addition is commutative for any numbers. In this case, for the arbitrary numbers a and b, a plus b equals b plus a. If the grouping of the numbers doesn't affect the result, an operation is said to have the associative property. In other words, if the placement of parentheses doesn't matter. For example, 2 plus 3 plus 4 would equal 2 plus 3 plus 4. See, these parentheses have moved. Let's test this. The upper blue arrows shows 4 added to the initial quantity of 2 plus 3. So first we have 2 plus 3, which is 5. So we end up here, 5 on the number line. Then we add 4 and we get to 9. Here, the lower red arrows show the quantity 3 plus 4 being added to the initial quantity of 2. 2 plus 3 plus 4 gives us 9. This shows that the grouping of the numbers doesn't affect the result. Let's show this, but for all numbers. The specific numbers don't matter. Addition is associative for any numbers. In this case, for the arbitrary numbers a, b, and c, a plus b in parentheses plus c equals a plus in parentheses b plus c. An identity property describes a procedure which does not result in a change. Adding 0 to any number does not change its value. On the number line, adding 0 leaves us in the same location. So adding 0 is the identity property of addition. For instance, 7 plus 0 equals 7. Since there's nothing special about the number 7, this is true for any number. A plus 0 equals A. The result of adding whole numbers together is also a whole number. This means that addition has closure over the whole numbers. Regardless of how many whole numbers are added together, the result is a whole number. Here's a summary of the properties of addition. It's commutative, a plus b equals b plus a. It's associative, parentheses a plus b plus c equals a plus parentheses b plus c. The identity property, a plus 0 equals a. And there's closure over the whole numbers, a plus b equals c, where a, b, and c are all whole numbers.